In 1984, sociologist Charles Perrow introduced the normal accident theory. NAT is a framework for understanding how accidents can occur in complex systems. In fact, how complex systems are more likely than less complex systems to experience sudden catastrophic failure. This is due to the inherent complexities and tight couplings of the system's components. Here are some of the key concepts of NAT. 1. Complex interactions. Perrow emphasizes that the different parts of a complex system often interact in unpredictable and incomprehensible ways. In systems with complex interactions, it's hard to anticipate how different elements will behave together, especially under unusual conditions. The United States government, for example, is a complex system. A priority shift in the House of Representatives could trigger changes in the behavior of the White House or the Supreme Court, and even local governments. 2. Tight versus loose coupling. Coupling refers to the degree of dependence between different parts of a system. In tightly coupled systems, processes occur in a strict sequence with little room for adjustment or delay. In loosely coupled systems, there's more flexibility and buffer space. Tight coupling in complex systems can exacerbate problems as a failure in one part quickly propagates to other parts. Still other systems, like for example the United States government, oscillate from loose to tight. During election seasons, or when a president is nearing the end of their final term in office, or when we are at war, the system tightens up and becomes more prone to failure. 3. Inevitability of accidents. NAT posits that with highly complex, tightly coupled systems, accidents are not just possible, but inevitable. The unpredictability within such systems, the inconceivable number of interactions and tight linkages make it impossible to foresee and guard against all potential failures. This inevitability, according to the theory, must be conceded and embraced. 4. Limits of safety measures. According to NAT, while safety measures and redundancies are important, they will inevitably be limited in their capacity to prevent accidents. In reality, the act of adding safety features and protocols will actually increase complexity, potentially introducing new pathways to failure. 5. System design considerations. Perrow suggests that to minimize accidents, systems should be designed with simpler interactions and looser couplings whenever possible. This is different from other models of crisis management which attempt to predict and institutionalize very specific plans to manage very specific crises. Thanks for listening.